Hi everyone, my name is Paul Jaising. I'm a senior advisory consultant at AWS. Today you'll also be hearing from Subra Seshadri, Vice President at Fannie Mae. I'm glad that you're joining us today as we go over the machine learning journey for loan evaluation at Fannie Mae. We'll do an overview of the machine learning pipeline, followed by a detailed overview of the implementation at Fannie Mae. AI/ML is universal and it will be in every aspect of systems, processes, and our daily life in the coming months and years. Understanding the fundamentals of the machine learning pipeline or machine learning lifecycle is important for every technologist and business leader. So before we do a deep dive into the ML journey for loan evaluation at Fannie Mae, I would like to go over the machine learning pipeline. See, all machine learning projects will go through these key steps. So let's dig in. You should always start with the business problem that you or your team believe could benefit from machine learning. See, the next phase is problem formulation. In this phase, you will articulate your business problem and you'll convert it to a ML problem. So in these two phases, the key questions to consider are obviously, what is the business problem? What is the business goal? What is the business metric? Why is the business problem appropriate for machine learning? And what type of machine learning should be used? Are you going to use supervised learning? Are you going to use unsupervised learning? Or going to the deeper end, reinforcement learning? So how do I reframe the business problem as a machine learning problem? So after you formulated your business problem, we move on to the data preparation and processing phase. So in this phase, you will do the data collection. You collect the data from all the different sources, maybe streaming data, batch data, maybe you already have it in a data lake in S3 buckets, or you have it in Redshift. You extract data from multiple sources. You integrate the data in a central data accessible place. See, then you do the pre-processing of your data and your data visualization to transform the raw data into an understandable format and to extract important features from your data. So you do this to ensure your data is formatted correctly for the machine learning algorithm and is cleaned up in a way that will maximize your model's prediction capability. So what are the questions to consider here? Do you have to make any assumptions about the data? What does exploratory data analysis and visualization tell you about the data? What techniques do you have to use to clean and pre-process this data? So once this data is prepared and ready to be leveraged by the model, by the way, this step takes anywhere from 60 to 85% of the total machine learning lifecycle. So I'm really excited about the newly released Amazon SageMaker Data Wrangler, as it will greatly help to reduce this time. So once this data preparation is complete, you're ready to train and tune your model. See, this is an iterative process that will be performed many different times throughout this workflow. So obviously, your model will not yield the results that you might expect in the initial training runs. So you'll have to perform additional feature engineering and tune your model's hyperparameters before retraining. So what are the questions to consider for model training, right? What percentage of the data should be training, validation, and test? Secondly, did you randomize the split? If you did not randomize the split, how might that impact the model? And then obviously, what algorithm should be used? So model evaluation is repeated until your model's evaluation shows that it's performing at the level required for your business case. So the key questions to consider for model evaluation are, hey, what metric do you choose to evaluate your model? How did your model do on your chosen metric? And finally, what did you learn from your evaluation metric? See, if your model does not meet your business goals, go back, reevaluate a few things, take a second look at your data and features for ways to improve the model and the way it's produced. See, building a model is a highly iterative process. You have to keep that in mind. It's a highly iterative process. You keep iterating. And once the retraining happens and you're satisfied with the results, your model is deployed to deliver the best possible predictions. So again, it's important to keep in mind there is no defined quote unquote end state here. Evaluation, reevaluating, retraining, and feature engineering, data augmentation is a highly iterative and an ongoing process. See, one area that AWS Professional Services focuses a lot on machine learning lifecycle, especially for financial services, is AI/ML governance. The key AI/ML governance constructs that we focus are model explainability. How explainable are the ML model outputs? Is it easy to understand for everyone? And secondly, performance, right? It includes the model functional and operational performance. Safety, focusing on ethical issues or other safety risk as a result of using this machine learning model. Fairness, does the ML model implement and perform any bias detection and remediation? See, for each data set used by the service, was the data set checked for bias? What efforts were made to ensure that it's fair and representative? We recently announced Amazon SageMaker Clarify. That's going to be very helpful in this process. Concept drift. The ML model performance could degrade when the statistical nature of data changes gradually, or the statistical relationship between the independent and the dependent variables changes over time. These are called data drift and concept drift. So what's the current approach to mitigate concept drift? What are the measures that you've currently taken to test for concept drift? By the way, Amazon SageMaker Model Monitor will assist in this process. Security, steps that you take to address security. How can this model be attacked/abused? How are users and information secured? What are the security policies in place? Then lineage, capturing lineage of your training data is extremely critical. Capturing third-party data information and the steps involved in the transformation of data. By the way, Amazon SageMaker experiments will assist in capturing detailed lineage info. And then your operating model. How does your operating model look in your company? From an organizational structure perspective, how does the existing processes in place for the machine learning groups in the enterprise? We see that we've been helping a lot of companies in the machine learning governance aspects. So if you're interested, I wish we had a Q&A today, live Q&A. Since we don't have it, please feel free to reach out to me. Our group, AWS Professional Services, would be glad to help you implement machine learning governance. So that's the machine learning pipeline, including the machine learning governance constructs. So at this time, I'd like to introduce Subra Seshadri, Vice President of Fannie Mae, who is going to go over the machine learning implementation that we did at Fannie Mae for loan evaluation. Subra, the stage is all yours.
Thank you, Paul. Hello, everyone. I am Subra Seshadri. I am a Vice President at Fannie Mae. As you may know, Fannie Mae's mission is to provide a stable source of liquidity to the US housing market and to support low and moderate income Americans. We are a government chartered enterprise. We operate in the secondary mortgage market. We have two primary lines of business: single family, which deals with 1 to 4 residential units. We have multifamily, which deals with 5 plus residential units. Our business model is we don't directly originate loans. We buy loans from the lenders and we package them and securitize them as mortgage-backed securities, which we will guarantee. With this business background, let me walk you through the business problem we are trying to solve and the business outcome. The objective is to risk rank loans based on loan property and market characteristics and to predict the probability of a loan going into troubled state in the first 2 years of acquisition. When I say troubled state, the loan status can be substandard, doubtful, or default. We used to do only random sampling. By random sampling, we were able to achieve a very low catch rate of 3.5%. By catch rate, I meant the probability of finding the troubled ones in the first 2 years of loan acquisition. By using a machine learning based approach, we were able to significantly improve the catch rate from 3.5% to 48%. Now we were able to do better risk management. We were able to take some early mitigation actions on high risk loans. So that's the executive summary. Now let's walk through a detailed approach, how we used machine learning for our use case, and followed by a detailed solution architecture walkthrough. As Paul mentioned, there are 7 pipeline steps for a machine learning pipeline. Pipeline 1, business need. Again, our business need is to risk rank loans based on loan property and market conditions and to predict the probability of a loan going into troubled state in the first 2 years of acquisition. Step 2, we have to formulate the problem. We decided to use a machine learning based approach to meet our business need. Step 3, this is where we collect the data and we integrate the data. We use both third-party data set and book of business data set. From a third-party perspective, we primarily use Moody's macroeconomic indicators. From a book perspective, we looked at our loan history. We carefully selected 10 years worth of data as a sample. We have to make sure data quality issues are addressed. We have to eliminate false positives. As an example, for some of the loans, we had incorrect financial statements uploaded by a lender. We have to address them. We only started with about 52 features. We need to make sure we only look at our standard products. Once we have all the data, now we are ready to massage the data, transform the data, and get ready for processing. We used Java-based processing to do the necessary transformation. We also used a third-party rules engine. When we acquire a loan, we are required to run loan compliance checks on our loan and property attributes, and those rules are defined by our multifamily seller servicer guide. So we run those rules, we obtain those results, and those results are also shown to the user for informed business decisions. So this is step number 3. We also want to address missing values. There were certain loans where we had missing values. So we need to make sure we impute those values. How do we do that? We look at all of the loan population for the missing variable, and we take the median instead of mean because the median is more stable compared to a mean value. And now we are ready to move into pipeline 4. In pipeline 4, now we have the data. We are ready to process the data through a machine learning model. The very first step, you need to convert this data set into a format a machine can understand. We use libraries like NumPy's arrays, Pandas data frame, etc., to convert the data set into a format a machine can understand. Once we do that, we run it through the model, we get the output, we use SHAP libraries to predict the magnitude and the direction of a impact from by a feature on the model output, which is our riskiness. Once we do that, we need to convert the data back into a format a user can understand. We use libraries like Seaborn and Matplotlib to achieve these results. Now we are ready to move into step 5. This is where we train the model and tune the model. As I mentioned, we pick 10 years worth of data. Then we have to segregate that into a 70-30 split. 70% of the data set is used for training the model. 30% of the data set is used for testing the model. Now, you take that 70% category, you further split that into 5 different folds. We call it a K-fold stratification technique. The way it works is, in the first iteration, you reserve the first fold purely for testing purpose. The remaining 4 folds are used for training purpose. Now you go to iteration 2, the second fold is used for testing purpose. The rest are used for training purpose. We repeat this iterations 5 times. Once we are done, now again you test the model with the 30% data we reserved originally. Why we do this? This is to avoid model overfit. Model overfit is a case where a model will closely follow the training data. We need to make sure our model we deploy to production predict a real life scenario. So now let's move into the next pipeline, which is 6. Here, we have to now evaluate the model. If you recollect, we collected the data, we transformed it, aggregated it, and we processed it. Now we need to find the right model that will meet our business need. We looked at multiple competitive models, and we finally selected a model that met our business need. One of the criteria we used to select a model was using the area under the curve. AUC is an industry technique to select the best model. And particularly, we used receiver operating characteristic curve, which is a type of AUC. When we do this analysis, we will create confusion matrix. We will have values like true positives, false positives, true negatives, model accuracy, etc. We have to plot true positives against the false positives. AUC is just one of the criteria. We have to make sure the model we pick, again, need to meet our business needs. In the end, from an end user perspective, when I look at the dashboard, I should be able to see all the risky loans ranked in the descending order. And if I focus on the top 15% or 10%, the model should maximize the probability of finding troubled ones in the top 10 or 15%. So I need to make sure I select the right model that meet my business need. So based on this, we selected random forest Gini, which met our business need. We ran sensitivity analysis on the top 20 features. How do we do that? We take a feature, you change the value, you run the model and see the impact of that feature on that model without compromising model accuracy. If you remember, we started with 52 features. And towards the end, we were able to identify the top 20 features which had a significant impact on the model output, which is our riskiness. Some of the examples of features that made it to the top 20 were a typical loan note rate and a loan to value, etc. Now let's go to the last step of a model pipeline. We need to deploy the model. We use SageMaker to deploy and run the model. We use SageMaker's batch protocol to trigger the model processing. We exchange payload in a file format, and we also deploy the model into the SageMaker environment. So now we went through all the 7 key steps of a pipeline. The very important thing we need to remember, once a model is in production, we need to have the discipline to monitor the model on a periodic basis. We have to do it because models drift over time. Models drift because the market conditions can change, the data set can change. So it is very important to monitor, predict the drift, and address the drift. At Fannie Mae, we are asked or we are required to predict the drift every 3 months as a good practice and address the drift. Before we do that, we need to address data quality issues. And as part of the analysis, we used to call it as in this analysis, we look at the drift over time. If you look at features, the features have impact on the model riskiness, and they drift over time. And we like to see those drift. The predictions will change over time. So we also do a prediction drift over time analysis. And once we estimate the drift, we use Python libraries to correct the drift. And finally, model explainability. As I said, we use SHAP libraries. We ran it on the top 20 features. We were able to find the impact as well as the direction of each of the top 20 features on the model output, which is our riskiness. And our end users are very, very keen to see what are all my top 10 features that had a significant impact on the model riskiness. And that was required by our business. So I would now like to spend time on end-to-end solution architecture. In Fannie Mae, we have multiple AWS accounts. We categorize them based on typically a business capability or based on a non-functional need like performance. And we have clear architecture patterns to exchange data between accounts. So if you look at step 1 here, we place the book of business data and the third-party data set into an S3 bucket, which is hosted in the multifamily account. Step 2, that's a trigger to a Lambda function, which in turn triggers a step function. If we look at step 3, a series of things happen there. There are 4 Lambda functions there. The first Lambda, which is the business rules, will invoke a third-party rules engine. As I said, we have to run several loan compliance checks based on our loan and property attributes, based on our multifamily seller servicer guide, and those results are shown to the user. In this case, once the results come back, we store it in a relational data store, RDS. The second Lambda, which is persist book of business, will persist the transactional data into the same RDS. The third Lambda will go to the RDS, retrieve the necessary attributes that are required for a SageMaker invocation. It collects the attributes, prepares the data set, and put it in a S3 bucket, which is hosted in the Enterprise Data Lake AWS account. Remember, our application is in the multifamily account, whereas the SageMaker platform is running on the EDL AWS account. After successful processing, the data is retrieved and the data is stored back in the same relational data store. Now we have all the results in one place, and now we can run various analytics for our end users. In step 4, we use Tableau dashboard to visualize the results to our end user. Our loan surveillance team, they can typically see the top risk loans ordered in descending fashion. They can see the top 10 features which had a big impact on the model riskiness. They can see the loan compliance checks we ran against our rules engine all in one place. Now they are enabled to make better, sound risk management decisions. Now let's drill deeper into our SageMaker design and implementation. Remember, SageMaker is hosted in a different AWS account, so let's go there. We interact with SageMaker. We deploy the model to SageMaker, so SageMaker has access to our machine learning model. We place the payload in an S3 bucket, which triggers a Lambda function. An SNS function now has two purposes. First, it needs to send the necessary metadata to our enterprise data catalog system as per our enterprise data standards. And the second purpose, the Lambda will trigger a step function. If we look at the step function, two things happen there. The first Lambda invokes SageMaker. It invokes the batch process. The second Lambda periodically polls SageMaker for the results. If the process succeeds, great. If it fails, we will retry. The results, along with the success indicator or failure indicator, is placed back in the EDL S3 bucket. And if you recollect, those results are retrieved and placed back in a relational data store, and we were able to render those results to our end users. So that's the end-to-end design of our machine learning implementation. Before I end the presentation, I would like to talk about some key takeaways. Number one, a machine learning based approach enabled us to manage risk effectively. We were able to deploy some early mitigation actions on high risk loans. We were able to substantially improve our catch rate from 3.5% to 48%. Number two, not only business knowledge, a real good understanding of the underlying data is critical for success. Number three, model monitoring on an ongoing basis and correcting the drift is critical. Ongoing model monitoring will ensure the model performs really well over time. And lastly, Fannie Mae is in the middle of digital transformation. We have many use cases where we can leverage machine learning and artificial intelligence that will enable competitive advantage for our business. Thank you.